Hello everyone, my name is Anastasia Kostenmacher. I already introduced myself last week during our first meeting, and today we will start with our lecture. The lecture is actually about the data science, and we will concentrate mostly on the data visualization, as you can see here, and statistic. This lecture and the next one will be structured in such way that visualization and statistic will not have some particular part on the visualization or particular part on the statistic. They will just interact together with each other, and you will see for which purpose. And then in the middle of the lecture, we could discuss why it's actually you will see and understand. I will also highlight this why it's done in such way. So let's start. I will start with the motivation. So why we actually, what is about data visualization and statistic and why we need it. Then we will go to the data extraction. So just because before to start to work with the data, we need to take the data. After that, we will mostly concentrate on the tabular data, because also the data for the project which you will get, they will done given in the tabular format. Then we come to the importance of the visualization. Of course, we can just deal with the data just using a simple statistic, but in some cases we will see that the statistic fails. We need something more. And actually why we need the data visualization. After that, we will go deeper, because before to do any of the visualization, we have to see which type of data we have. Because for the different type of data, we can apply different kind of the visualization. Then actually the purpose, why we need statistic, why we need visualization, in order to see how good our data, in order to see the quality of our data. After that, we will start to show that good, we are working with the visualization, but our data could be done in the 1 dimension, 2 dimension, multiple dimensions. And here we have to decide. Since we are human, our human eye, and visualization is done mostly for us, for expert, for human to understand. Can I see something from the data about this data if I just present it in that way? And if we try to visualize in the 4 dimension and even in the 3 dimension, we cannot see anything. Our eye, human eye, cannot process such kind of information. Therefore, we'll just see that, okay, we will concentrate on some single features from our data set. We will learn. Don't worry if you are not can follow what means the features. We will learn this during our lecture. We'll concentrate on some single feature, and then later on see, maybe we can combine 2 of the features and then give us a nice visualization. Okay, next step, we'll see what we everything need in order to prepare for the analysis, because very often why we need visualization and statistic. The main purpose for that is that we want
Nastya, just excuse me, I think Agatha wants to say something.
Yeah, please.
Sorry to interrupt you because Professor Amanda is trying to enter in the class, but she couldn't. I think someone has to authorize her.
No, I don't, Rebecca, it must be you because I didn't got any ask as a, any permission solicitation.
Normally, you have to add this number, and maybe sometimes
No.
it asks the password. So
I
the
can-
password is given.
I am going to send her what she needs. Just a
I
moment.
can let them in because I have also not.
Just a moment.
Mm-hmm.
I will take a look if I can let them in.
Just a moment, sorry. It's
Don't worry, everything is good.
she's writing me right now. I sent her the password. I think in a few minutes she will be here with us.
Then maybe I can continue if it's
Yes,
fine
yes,
with
it's
you.
okay, Agatha. She will catch up with.
Okay,
Yeah.
so, well, we'll look how we can combine the features in order to show better visualization. After that, we actually will see that why we need the visualization and statistic. And the purpose, the goal why we need it is to prepare our data set for the further analysis. With the visualization, we already as a humans can make a first conclusions about that our data set somehow, what we can say about our data. But actually the important purpose is to analyze the data, to apply machine learning techniques, and that's done in the steps. And finally, the last part of the whole lectures is we'll just see some poor and good visualization as well as interesting examples with the statistic. I have a bunch of examples. There are some of them quite funny. Also, how you can lie with the statistics. Okay, let's just start. We start with the visualization. So what is, and in general, what I would like to give you with the first introduction, actually, we're talking about data, about the visualization, everything. Let's to put them in the context, why we need it. The people who is working with the data, the jobs which are connected to the data, they're referred to the data science. The purpose, the goal of the data science is to take the data in the form whatever they exist and to produce some value, to extract some information, to get a better knowledge about that. And then this knowledge can be incorporated and we take appropriate actions of that. So all these items is done by the people who call themselves data scientists. But what is data science? And actually, data science is a set of methodologies for taking data, which is given in the different kind of forms. You can see here, data is given as emails, or you use your bank card to pay something, or you get the tweet, or you have some Excel data sets where the information about success of the company, or you have the sensor readings. So you take the data. Data is given in thousands of forms of representation. And use this data to draw a meaningful conclusions. And the data is collecting all around of us. Every like, every click, every email, credit card swipe, tweet. This is everything a new piece of data that can be used to better describe the present, in order to better predict the future. Okay, so how do we start to use data? In data science, we generally have a workflow. And this workflow consists of 4 steps. So for any project, what you're working, you need to do these 4 main steps. And the first step, as you can see here, first, we collect the data from various sources. In our case, in your project, probably you do not need to collect the data. The data will be given. But in many cases, you first need to do some experimentation with some tools sitting in lab, or for example, in the medical purpose, it will be some study for the data collections, and so on and so forth. very often the data have to be collected. So after the data are collected, and we have to store it. And we will see, depending on the type of the data, the different types, various kinds of storage can be done. So this was our first step. We collect the data and store them. We can store them in the computer. We will see a little bit in more details further what means that. Our next step is data preparation. And this includes cleaning data. And this is actually a very important step, because the data which come to us, they very often have some missing entries. They could have some duplicates. Think about, we want to do the medical study. We collect the information about the patients, and the people just adding, or the patients adding some items to some given tables. And this is our data. And some person, just for it or her age, instead of 20, just by accident add the extra 0. And this is a 200. So you see that some small fault, we as a human can immediately detect this, but we want to. And this kind of faults occurs always. And it is in our raw data. Therefore, this step when we need to prepare this data is so crucial and important. After that, we go to the next stage. And this is actually where the most time we will spending during our lecture. Exploration and visualization. The purpose of the exploration and visualization that we try to understand about presence of our data. We try to understand, okay, given this data, I can tell like this. I can make the conclusions about today's stage of the company from which I get this data, of the study from which I get this data, of the person from which I get the data. I can say about the present what is about. And the fourth stage, we would like to use the data in order to predict the future, in order to say, okay, what we can do. For example, think about the study, the student study. We collect the data about the students who started some semester, who started statistic course. Then we observed during the whole semester, then how often the students was attending the lecture, how often they was doing their homeworks, and then finally we can see how good they passed the examination. And based on this data, we would like to learn what could we do, or what can students do in order to get a better grade for the examination in the statistics. That can be done in this fourth case. So, as you can see, this is where we will concentrate us in this lecture mostly, and this is the main step which every data scientist is doing. And very often in the data science, that not just a single person preparing these 4 stages. You have data engineers who is working on the collection and storage of the data. You have the statisticians who is preparing the data. You have the machine learning people who is actually do these 3 stages. So the whole field data science can be split into the various areas, which each of which correspond to some particular beruf, how it will be correctly in English, profession.
Yes, profession.
Okay. So let's to start with the data. We saw the first step, we have to collect the data. So we are in our daily generated a vast amount of the data simply by using internet, tracking around or paying by card in a shop. The companies behind those services that we use collect this data internally. They use this to help them to make some data-driven decisions. So that means we have some step where the data are collected and taken by the company. On the other hand, there are also many free open data sources available. This means the data can be freely used, shared, and built on by anyone. So, and there are multiple ways. So we have the company data and we have the open data. And there are multiple ways to access this open data. Two of them are IPs or public records. IP stands for Application Programming Interface. And it is an easy way of requesting data from a third party other than internet. And many companies have these public IPs to let anyone access their data. And some notable IPs include Twitter, Wikipedia, Yahoo, Google Maps, but there are many of them. So using this open source, you can access the data. On another hand, we have also, for example, to play around, or if you have some small amount of the data and you would like to extend it to make your research deeply, you have some special websites which offer you, like a Kaggle, which offer you open source of data. So the important point, we have the company data. We also refer to them sometimes as private data. And we have an open data. When we're working with open data, we can forget about everything. Just take this data, do whatever we wish, publish results, and fine. But if we use with the private data, company data, we have always to think about the other important topic. This is a data ethic. The data that we have is an incredible resource, and we can get an amazing value from it. But we need to be respectful of the data and the people who have given it to us. So think, if you use some private data, please acknowledge, ask the people if you're allowed to publish this, and be very careful with this type of data. Good. Let's go to the next step. Type of data. Which type of data could we have? We could have quantitative data. Quantitative data is very easy. Everything that is deal with numbers. We have the numbers. This is the quantitative data. But we could have also qualitative data. This data deals with the descriptions. For example, take refrigerator. Everyone probably in our flats have the refrigerator. Then we can say that what we can say about the refrigerator in its qualitative view, that it is 1 meter 60 centimeter tall. Then we can open the refrigerator and it has 2 apples. Again, the number 2 items. We can have a price about this refrigerator. It cost 700 euros. This everything belongs to quantitative data. This type of the data refer to it as a quantitative. The other type of the data, we could say that our refrigerator is red. Well, mostly of the time it is white, but or it's made in Italy. So as you can see, I have some new messages. Okay, that's not. It's made in Italy, so we cannot put it as a number. Or if we open it, it smells like fish, so somebody have to wish it. This type of the data, we refer to them as qualitative of the data. They describe our data. They describe the object, our object. Good. We know that we collect the data. We know the type of the data. Now, let us discuss efficient ways of storing or retrieving the data that was collected. And as you can see, this is still part of the first step in the data science workflow that we defined before. When storing data, there are multiple things to take into consideration. First, we need to determine where we want to store the data. Then, we need to know what kind of data we are storing. And lastly, we need to consider how we can retrieve our data from the storage. What do we think? Where can we store the data? Do you have any ideas? Can somebody tell me where it can store the data?
Sorry, can you repeat the question? I didn't understand very well.
Okay, so we would like now to store our data. What do you think where we can store the data? Think very simple. It's a quite simple question.
The location where we store it in a hard disk. Oh, yes, somebody mentioned it here, hard disk.
Yeah, exactly. The point is here, if I have the small amount of data, it's fine to have only our PC. And normally, probably for your project, you just have your own PCs and you store the data and you're happy with that. In the case, if you have large amount of the data, normally in the companies, you have multiple PCs or they build together the cluster or server where you can put your huge amount of the data. Or alternatively, you could pay another company to store data for you. This refers to us as cloud storage. Common cloud storage providers include Microsoft Azure, Amazon Web Services, Google Cloud, and so on. Those services provide more than just data storage. They can also help you organize with some organization, with data analytics, machine learning, and some deep learning. Okay, so the next point, what we need to know about the data storage is that different types of data requires different storage solutions. Some data are unstructured. This is like, you can say here, like email, text, videos, audio files, web pages. This type of data is often stored in the type of database which called document database. Sorry, here I have used the German word. It should be database, not Datenbank. I'm sorry. More commonly, data can be expressed as a tables of information, like what you may find in spreadsheets, Excel spreadsheets. A database that stores information in the tables is called relational database. Both of those types of databases can be found on the cloud storage providers that I mentioned earlier. Data querying or retrieval. Once data has been stored, in a document database or relational database, we will need to access it because we store the data, we place in some, and now it comes there. Another specialist which try to work with our data, not the data engineers anymore, data analytics or machine learner, they would like to access the data. At the basic level, we will want to be able to request a specific piece of data, such as I want to see all the images that were created yesterday in August 23rd. Or want to see all of the customers with the addresses in Brazil or in Germany. So we can give this query and would like to very fast access the reply. In addition, we might even want to do some analytics, such as summing, counting, or averaging the data. Each type of database has its own query language. So document database mainly use NoSQL, while relational database mainly use SQL. And SQL, maybe you know, stands for Structured Query Language. And NoSQL just stands for Not Only SQL. So very easy. Oops. Yeah. Well, we cover everything what we need to do for the data storage very briefly, very generally. And now let's come to the data preparation. Data preparation is a very fundamental. Data scientists spending 80% of their time cleaning and manipulating data, and only 20% of their time actually analyzing them, applying machine learning. So if you get the data in their raw format, be prepared. That first comes not the cool job when you apply machine learning algorithm and can see, or deep learning methods and can see amazing results. First, you need to prepare the data. You can think about that like so. You would like to make a soup. Prepare the soup for the dinner. Vegetable soup. For that, you need first vegetables. But you cannot put the vegetables as it is in your top because doesn't matter how good your vegetables will be, probably it will not be tasty. First, what you need to do, you need to clean vegetables, you need to cut them, peel them, you need to prepare them. The same with the data. Without cleaning the data, you will not get any results. They will break your algorithm. They will give some strange provide you some strange conclusions after the analysis. Sometimes there are some in the data science language words, garbage in, garbage out. So therefore, pay attention.
We are not seeing, excuse me, we are not seeing your slides. So,
Now?
Now again, yes, it's okay.
Yeah. Sorry. Thank you. Thank you for letting me know, but I don't know why it's happened. But so, data preparation. Let's do the very small exercise. This is our data. So we collect the data about some people. You could see here the people with the names of the people and about some properties of those people. So here you see 3 properties. Oops. Somehow. Yeah. Our first step, we need to hide our data. Normally, when you work with the tabular data, you see here the tabular data, then as a rows, you have your samples, the examples of your data. And as a columns, you have the properties of every example. So here, our first step, it's clear in this table, the people, this is the examples, samples of the data. We just collect the information about different people. And age, size, or country, it will be their properties, description about every person. So therefore, our first stage, let's to bring this to the common correct form, so that we have first, this is our how it was before, and now how you can see it now. We have the name, some description. Here we have our people, and here you have the description of their people. So we have, for example, Sarah. She is 27 years old. She is 1 meter 77 centimeter, and she comes from Belgium. Then we have Lise. She is probably 30 years old. Yeah, she has, then it's given her size and the country where she come from. So that was the first step. We introduce it in the right order, just put rows is always our examples, and columns, it's the description. We refer to this description as a features. Now the next step, remove the duplicates. You could see here that Lise come twice in our small data set. So just let's to remove the Lise, which we do not need. Check. So, and we have, you see our next step, we have now no duplicates in our data set. Okay, let's go on. Continue. It is also very common that we not use the name, since we're working with the computers need to refer to every sample in some easy and concrete way. And the names can repeat itself. That's the first. The second, the names could be too long and not comfortable to deal with. Therefore, we address to every data point a unique ID. So we add just an additional column where we enumerate our datasets. Next step. Oops. Homogeneity. So as you can see, our people come from different countries. And in those countries, you will see that they are given in the different way. Sometimes it's given the country name as in general, as a full name, Belgium or USA, or just the abbreviation. So what is important here? We would like to have just one common way to present the country name. Or if you look to the size, could you see here in the size? Is everything fine with the size, or you have some doubts about the size? Look at the numbers.
So I think one is in meters and the other one is in a different Einheit.
Yeah, exactly. Here you see that this cannot be 5 meter 58 centimeters. It's probably given in feet. Well, we have now to convert this also to the same units. And here you see now we have the countries. and units or for the size given in the same way. Our next step, we see what is missing. Data types. You could see we have the age here. And the age is actually here given in these quotation marks, is given as a string. If we directly give to our PC this format, it cannot do it. It can only deal with these entries like with the words with the strings. But this is a numbers. And we would like probably to make some analysis of these numbers to say either person young or old, or that one person is 2 years older or twice as old as the other, and so on and so far. We want to apply some mathematical operations. And if this is given as a string, we cannot do this. So we know as an expert age, it should be a number. We could convert this to the number. Okay. Like we done here, just simply now it's the proper conversion and we know that the type of this data type age is correct. Missing values. So the other point, what you can also notice here, for the example, Adrian doesn't have an age. Maybe by aiding himself, he either forget to do this or for some other purpose didn't do this. Okay, we need now to deal, and there are different ways how we could deal with the missing values. In our case, we can just take the simple one and just take the average. Of course, this is actually not always a good proper solution. The best way would be to find Adrian on task. Hello, how old are you? We need to put your name to our database. But if we couldn't do this, then we just simply could take the average or could add some last number. So here we took the average and could add it. So as you saw before, as I introduce you, once again, these are our missing values, and this is our table, which we get in the end after doing the whole preparation result, after doing the whole data cleaning. Okay, so we have our 3 stages. We introduce it now a little bit more, our 2 stages, I'm sorry. Introduce a little bit in more details our 2 stages. It's a data collection and data preparation. And let's go to the data exploration and visualization. So the first, what we can do with the data is apply some statistics. This is actually what we also will do in these lectures. Assume we have these 4 data sets. Data sets 1, 2, 3, and 4. And every data set consists of 2 features, feature X and feature Y. Y, sorry, X and Y, X and Y. And now our first step, we will take some statistic. We apply some descriptive statistic in order to analyze this data. We can take the mean value and the variance for every X feature of our 4 data sets. And if we will compute it, calculate it, we will get that our X is the same. We can take the variance for every X feature of every data set. After computing this, we can get also the result that for every 4 data sets, we have the same variance. The same we can repeat for the Y feature. We can apply the mean value compute the mean, compute the variance for everyone, and see what the result will be. Similar, we can do, or the other statistical, classical statistical approach, what we can apply and get some information about the data is just simply try to fit the linear regression, the line to our data and see the parameters of the line. And here we get again the result that it's the same parameters. The line which we will fit in all our 4 data sets are the same. So what it gives us that the mean values, the variance for both features x and y, the correlation coefficients, they are the same. So we can just make a conclusion without doing anything, just applying the statistic. Well, we have 4 identical data sets. Very good, mathematically perfect. But now let's visualize our data set. Somehow it's why it's freezing. Wait, I try to probably close and open it again. Here. Let's visualize our data set. And you see the first data set, it has just this orange dot. Here's x, here's y for the first data set. The second data set is the dots are in some line in some parabola, as you can see here. In the third data set, you could see the points are lying perfectly on the line, but we have one outlier, which makes the whole line and change the mean value. Our fourth data set, it's again, the data could lie on one line, but this line is perpendicular to the x-axis, and we have one outlier. So if we apply the statistical methods, it gives us 4 identical data sets. But if we try to visualize it, we could immediately see that's a different. And for example, if we will consider the data set 3 and 4, if we simply just remove our outlier, so we just remove these points, they will give us completely different results, which is actually will describe the best of our data sets. So therefore, this is the first step, why we need the visualization. So, one picture is worth 1,000 words. So we can say, based on what we saw in the previous slides, we will tend to agree. Exactly. Just wants to visualize, it's give us a lot of information. And if a picture is worth 1,000 words, then what is worth 1,000 pictures? This is a dashboard. Well, technically, a dashboard of a few pictures is enough already. We do not need to have 1,000 pictures. My point is showing several pictures together can be more insightful than looking at them separately or trying to pack all the insights in one graph. For example, the dashboard, a very good example of the dashboard you can see in the cars. So you could see they include here the speed of the car, the motor rotation speed, and the proportion of the gas, what you can see on the right picture. So individually, those pieces of information are useful, but together they paint a much bigger picture and make your trip more safe and more comfortable with the car. So the other examples of the dashboard is you could see here. So what does this dashboard do? It groups all the relevant information in one place to make it easy to gather insights and act on them. On this dashboard, any sales person can see not only how sales are progressing this quarter, but also how this progression compares to the previous quarter. So on top of that, they can keep a track of transaction and opportunities, as well as of customer count. So you could see that a lot of information putting together for some experts could be give you their view about the good picture, about the years, maybe the whole year progression in your company. Okay, questions so far to our to our workflow. Okay, if there are no questions, then I have question to you. You see, this is the components of our data science workflow. Now, think 1 minute and think the order. What would be the first? What will be the second? What will be the third? And the fourth step in our data flow. And if somebody are ready to tell me, please, I would be happy to hear that.
I think first would be data collection and storage, then you prepare it, and then you go for exploration and visualization.
So
And
this
at
is the
last,
first, the second, what was the second?
preparation,
Right, okay, and what will be the third?
exploration and visualization,
Okay, and the
and
last?
finally prediction.
So, sorry, this is wrong. So exploration and visualization, the green one is the third, and this is the fourth, the exploration. So does somebody have to add something to add to that? So what is with my iPad today? Wait, just very briefly. Yeah, this is absolutely correct. The order or the steps of the data science. So it's the first, then we have second preparation, third exploration and visualization, and fourth prediction and experimentation. Correctly. Okay, let's go now. Let's again in the clean stage, how it should look like. And let's now continue with the, I think I will suggest we will do now the small break before we will continue with extracting the data, because it's just good point to have small break. So then we now will play with other stuff. Okay?
Okay, 10 minutes or how long?
Yeah, for me, 10 minutes is fine. So then at 2 o'clock, we'll be again here. Okay.
Okay, see you guys soon.
Okay, I hope that my iPad will work better now, so that it's not so freezing time to time. Well, I think we can continue. So this is a 1 minute till 2, but we wait a couple of seconds and we'll start at 2 on point. So just to check, yeah, everything's working. Okay. Very often, if you take some data science course or machine learning course, and you need to do an assignment there using some real data, the data is handed to you in the plate. But if you're working in the company, then it is not so simple. For example, if you have a person working in a call center, that person may use 100 different applications to collect calls. So every simple job might touch many different information systems. If you look at a system like SAP, it will be 10 or 1,000 of tables. And if you go to a hospital information system like Epic or ChipSoft, then in this information system, you will find 1,000 of tables filled with patient's information, and that could be done in the different systems. So if you're analyzing a certain process or you are analyzing a certain disease, it's not so simple. So the extracting the data is challenges. And to do data science, we need to bring it down to well-organized data sources that are not too heterogeneous, because otherwise we cannot do anything with such type of data. Therefore, now we come to our main topic, to the visualization. But first of all, to do the visualization, we need to talk about the data type. So we could have structural data. Structural data, this is either numerical data, where we have age, time, temperature, everything which is done with numbers, or this is a categorical data. This is agenda, color, country name, class name, and so on and so forth. So this is the structured data. The unstructured data, this is everything that we cannot put on the table. Text, video, audio, image, signal, and so on. Let's look closely to the structural data, because in this course we will focus mostly on the structural data. Because if you do the analysis of the text or images, the principles of this analysis will be very simple. Now, if we zoom into structural data, we can see this type of taxonomy, as you can see in these slides. So we can split the structural data into the numerical and categorical. And we can further refine this. You should be able to explain what you can see in these terms. So the numerical data can be more split in the discrete and continuous. The discrete data is nothing else what could be counted. So if we can count how many people are taking part in our course, then it's a discrete data. If we, for example, would like to measure the speed with which the car go on the road, and the speed should be given with some accuracy, maybe 5, 2, 3 digits after the comma or point, then it will be the continuous data. Because if you put the radar and check the speed of the car, every time we will get another number. It will no single car which drives maybe 50, which is allowed here inside of the town to drive in the streets in Germany. So that would be the continuous data. Almost very often the physical units are presented like kilograms, so like kilograms, speed, not kilograms, weight, speed. It's mostly the continuous data. The continuous data can be further split into the interval data and ratio data. So interval data, this is the type of data which doesn't have true zero. What does it mean? Very often time, if we take time in Celsius, so now, for example, in Germany, let's say around 26 degrees of Celsius. That's the interval data because the temperature doesn't have the logical zero. We cannot say that tomorrow will be twice as warm as today. We could only say that tomorrow is 2, 3, 5, 10 grad more than today. So we cannot apply with this data multiplication or division. Well, we have some zero, we have the Celsius zero, but we cannot say that today is twice as warm as yesterday. And the other type of continuous data is ratio data. This is the data which have some true zero. For example, we can compare this car has the speed which is twice as large as my car. That's about a numerical data set. This is the categorical data set. The categorical data set can be split into the nominal. What's here? What's above here? Into the nominal or ordinal. Nominal data, this is just separated data. For example, colors, red, blue, green, orange. We can say that the colors are different, but we cannot put them on the order or to do with them something else. Or it can be ordinal, as for example, grades, school grades. Here in Germany, the grades are from 1 till 6, and 1 is the best, 2 is the second best, 3 is the third best, and so on and so forth. So we can put them on the order. Or you can think about the sizes, but yeah, or you can think about the dress sizes. For example, we have the small, small, size medium, and size large. It could be XS, X small, or X large, XL, X large. And we can put again them in the order that XS is the smaller size, then comes S, then come M, L, and the XL is the larger size. So we have the ordinal data. We could put them on the order. Now I have some small questions to you. You see here the some features. For example, number of items is equal to 6. Color of refrigerator is red. Dropouts, the number of students, 33% has dropped. Statistic class, for example. Date and risk. Risk is minimal. Could somebody, or could be at the same time, many of you, tell me to which type of the structural data belongs every of these blue boxes? What do you think? Don't worry to have the mistake. We can then discuss together why it's like this or why it's not like this. So take the first one. Number of items is equal 6. Is it numeric or categorical data type? What do you think? Don't be afraid.
I'd say it's
Good.
numeric.
Exactly. It's a number. 6 is a number. Very good. So it's a numeric. Now the second question, is it discrete? Is it countable? Or this is a continuous? We cannot count the number of items. What do you think?
It's discrete.
Correctly. So number of items is discrete. Good. Now let's go color red. So color red. Our first question, is it numerical or categorical? What do- Mhm.
Was talking.
Pardon?
I was going to say categorical.
Exactly. It's a categorical. Now the question, categorical, it could be nominal or ordinal. What do you think? Is it color, red? Is it ordinal or nominal? Any ideas? Again, ordinal, this is everything what we can just only differentiate. This is different from that. And ordinal, that we can put this in some order. So here we're dealing with the colors. It could be red, it could be green, it could be yellow. Can we put colors in the order that first the best color is red, then the second best is green, third best is yellow, and so on and so forth? Could we do this? Or it's rather nominal because they differentiate, but we cannot put them in some order. What do you think?
I think it's nominal.
Exactly. I would say also so. It's a nominal, so the colors is nominal. Now let's go to the dropout. What is with the dropout? It's the percentage. Is it first nominal or categorical?
Categorical?
I wouldn't say
Oh,
because
sorry, it's numeric. Yeah, it's actually
yes, it's
yeah,
numerical.
numeric. Yeah,
I'm
sorry.
sorry, I myself made a mistake. Ask nominal or categorical.
Yeah, exactly.
It's numeric. So now, just give you one tip. If you
Yeah,
think about the percentage just
continuous.
goes exactly. Yeah, it is continuous. And is it ratio or interval data?
Ratio.
Exactly. This is ratio data because we can say that 100% is a half of the 50%. So we can apply multiplication and division on that operation. Now let's go to the next example, date. What about the date? Is it numeric or categorical?
Categorical.
Rather, I would say it's numeric because you could see the numbers and we can put
Okay.
also the date. But the point is the date is quite complicated. The date is numeric, it continues, but this is the interval. It doesn't have a pure zero. We cannot start say what's the zero in the date is. We cannot say that, for example, tomorrow or in 10 years is twice as much, then till what? We don't have the logical zero. Okay, we can say the zero is the area after the Christus was born. That's with the date, it's always difficult. The date is always belongs to the interval data. Other questions, what about the risk? Is it numerical or categorical?
I think in this case it seems categorical, but it can represent risk numerically as well, depending on
Yeah.
the.
You can represent risk also as a percentage, absolutely. But in our case, it says risk is minimal. So it's
Yes, it's
categorical.
categorical.
The next question, is it nominal or ordinal?
Or,
Exactly, we can say, yeah. Perfect. Well, here's the exact result. Now, once more, the second example. So we have the temperature. Temperature 18 degrees Celsius. What is this? Now my question also that you can explain, discuss why it belongs to this particular type. So what do you think about temperature? You start to say it's numeric, then you can say or categorical, then you can say for the numeric is it discrete or continuous, and so on. What do you think with the temperature? Don't be afraid. You did it perfectly so far. Okay, if it's now too much, let's just start from the beginning. Categorical or numeric? Date. I'm sorry.
Numeric?
Categoric. But we
No.
have here, yeah.
I was saying numeric.
Yeah, I'm sorry. It was acoustically for me. I understood as a category.
Oh, yeah.
Exactly. Numeric or no? It's too early to put it as yes, it's numeric. Then the next, is it discrete or it's continuous? Think about also it's a physical event time, and it's not just 18 degrees Celsius, it can come the minutes and so I will just give you the hint, it's a continuous. And now the point, is it interval data or ratio data? Does temperature has a logical zero? Can we say that now in Germany is twice as warm as in, let's just say, Siberia?
Yes, so it's ratio.
Exactly, it's ratio. So, no, sorry, it's not ratio. We cannot find in the temperature the logical zero. It's an interval data because we actually cannot multiply the temperatures. We cannot say that yesterday it was, we can say that yesterday it was 2 degrees more or less. We can say that in Germany is currently 20 degrees warm than in Siberia, but we cannot say that it's twice as warm because we don't have this logical zero for the Celsius. So the temperature, it's the interval data. The next question, what about their country? Country genre, Germany.
Sorry to interrupt you, but I didn't understand why it's interval. Can you explain again, please?
Yeah, let's go to the temperature. So if you think about Celsius and the temperature, we have the 0 and they have the minus temperature and the plus temperature, right? And if we take now the temperature in, for example, in winter in Siberia, which is minus 30, and the temperature in Germany, which is plus 30, then we couldn't logically tell that the temperature in Siberia or temperature in Germany in the summer twice or 4 times as warm as in Germany. Since our zero is not logical. For the speed, we can apply. For example, if we have the car speeds, we have also 0, but we don't have really negative data. The negative data is when we go back with the car. Good image, but normally not. It will be also speeds in the positive data. So with the speed, we could say that this car drives with the speed twice as much, but not with the temperature. Normally, with the temperature, you could apply only 2 mathematical operations, plus and minus. You can say today is 2 grad more, yesterday was 2 grad less. In Siberia, in winter is 30 grad less than in Germany in winter. But we cannot apply multiplication and division to the interval data. We could not say that, again, in Siberia is twice as warm as in Germany. There are some limited amount of the cases which actually belongs to this interval data. It's a temperature but also there are, I forget, because there are temperature could be expressed in Celsius, in Kelvin, and in Fahrenheit. And I think in Fahrenheit, the temperature is ratio data, because in Fahrenheit you have the minus, you have the zero under the minus 240, or I don't know where this minus, but then you have the logical minus, or zero.
Yeah, but we have to consider. I don't know if it's important because we are talking about the universal unit system. It's not Fahrenheit included in it, of course, but the United States they use it.
Exactly, but
I think the only
point
country in the
here,
world.
just think about the other example of the interval data, human IQ. You have two people, the human IQ by both people will be measured. And you cannot say that one person twice as clever as another one. You can only say that this person has 2 points higher IQ than the other one. So again, you cannot, there are no logical zero. You cannot say when the person doesn't have IQ at all. You see, again, it's somehow more feeling point. But the IQ is another example where you cannot have this logical zero. I hope I could explain you. But if you have the questions, don't hesitate to ask.
Oh, okay, thank you.
Okay, good. Then let's go to the age. What do you think about the age? First, is it numerical or categorical?
I think it's numeric.
Exactly.
Discrete.
Exactly. I would say also.
It's in years and not in days or seconds. That it's
Definitely.
discrete.
Yes. What about the score?
It's categorical and ordinal because you can sort it.
Perfect. Absolutely correct. What about the speed?
Ratio data, numeric.
Exactly. Yeah. It's numerical and ratio that we can do everything with that. We can multiply, divide, add, and subtract. So, as you can see, when we have the data, we have normally features, some information about this data. And these features can be presented with a different type. And depending on that type, you can use different visualization examples for that. And we will see it later as well. It was structural data. Let's go now to so this was the example, unstructured data. I put them, also I already mentioned that we will mostly work with the structural data just to see that you're familiar with that. The examples of unstructured data, it's like they are not presented with the numbers. It's the text. This is the audio, this is the image, some signal or some video. So they are unstructured, we cannot put them on the tables. Okay, here what we were doing now so far. Don't worry, we are not now at the data extraction, we are at the tabular data. Okay. What we are often will use is a tabular data. And what we already saw, the columns called the features. This is our features in the tabular data. And the rows called are instances or samples. Here is a very small example where every row corresponds to an instance. And the instance in this example are orders, and the columns correspond to the features. So you see the first order, the customer orders some particular project with some particular price, the time when he ordered the project, and then is it complain about the project or not. So that's the features. And as you can see, we can again try to put every feature into our taxonomy. Like you can see, ID, it's categorical and nominal, because we can only differentiate. We cannot do anything, put on the order or do something, although it's a numbers, but we actually cannot sum up to IDs or subtract, multiply, and so on. We can only distinguish this ID is different from another ID. Product, this is also nominal, because we could say that we have product 780 Siaman, then we have another product, and so on so far. Price, as you can see, it's a ratio data, so we have price, euros, and cent here in Europe. Date, the interval data, we don't have some logical zero. And complain, so if the person complain or not, that's also nominal data, because we can only distinguish that it's either the person complain or not. Here is another example where we also use a little bit unstructured data, where we have images. For example, here also some information, some smiley, which is every instance, every person are putting. So you see here the person, they're sending a messages from each other, and then the text of the messages and the images added. And here you could see that person, here is you and Peter, it will be nominal categorical data. Message, it's some unstructured data. We cannot classify this in our taxonomy. Images also, but the data is again an interval data. Features. If we look at the features, at the columns, then they can be raw. They can be direct observed, or data entry by, or this type of data can be entry by people, or they can be derived. For example, if we have such type of data as a signal, every data sample presented by such information, then probably we cannot put all these points. We'll just take the mean value here and put as a feature a mean value like 15. Or we can put about, again, I draw the signal. Again, we have our signal. It can be expressed by one feature. It could be the mean value of the signal. The other feature, we can take the integral over the all points. It will be the second feature. The third feature, we can say what's the maximum amplitude of the signal, and so on so far. So you see that features could be raw, which is immediately given, and so, or they can be derived, like maximum, minimum, average, rank, bin, or something like that. Then the other features, specific features which play some specific role, is a time. Time cannot be decreased, because very often we predict, we started with some present or past time, and then we go to the future. So it's always increasing. Very seldom where we have the data which is in the decreasing, or the time is taking some accidentally. And we have also some specific features to which we refer as descriptive features or target features. And here is an example. Oops, sorry. Now I have to wait. What is today? I hope. Yeah, we are here. So, what means label data? Here, for example, what for us important is we have the features which described our product. And then what we would like to know is, based on the data, we would like to say if the person are happy with the product what they buy or unhappy. So when we apply machine learning techniques, then we take this red box in order to train our algorithm to predict the green box. So we would like to know which products the people, with which products are people happy, which products they are not happy. So this type of features, if they're given, they have a special name, target feature, or labels. If we think about the machine learning and data science, then very often when you use different sources to read about the algorithm, books, articles, then they use different terms. For example, sometimes the alternative terms for the descriptive features could be the predictor variables, the independent variables, and the alternative terms for the target features could be response variables, dependent variables. Also, sometimes the instances, you call it individuals, entries, samples, cases, objects, or records. It is for you to know, to be sure, if you just read some another source in another book and you see, okay, they're talking now not about the instances or samples, they call them the cases, so that they are sure that it's the same. It's just synonym to the word instance. Okay. Here we have the examples of unlabeled tabular data. Because I didn't select the target feature, we are distinguishing between labeled tabular data and unlabeled tabular data. And the difference is if we have the labeled tabular data or labeled data, then we are dealing with the supervised machine learning techniques. When we don't have a labeled data, this is our unsupervised machine learning techniques. Okay. If you're analyzing the data and you want to present it in a way of table, like shown here, you need to do some feature extraction. And in this case, I have just labeled images with a cat and dog. And I defined some, features for my data. So I will say that the type of animal, I have a cat, I have a weight of the animal, age of the animal, and so on. So, as I mentioned in the beginning, our focus will be very much on the tabular data because they are mostly presented and 80% of problems can be translated into the tabular data. And as we discussed before, we have instances that correspond to rows and features that correspond to columns. We distinguish special features. If there is temporal feature, so time, then it is often has some special role. You can think of time series analysis or the ordering of events when you are doing process mining or sequence mining. So time is also a special feature. If we are doing a supervised learning, we also need to have the target feature sometimes. And we refer to such type of features as a label. So what you can see at the bottom here, that if you look at the books, there are different terms for those concepts. So in these slides, actually the main purpose of these slides, everything what I was presenting you in the previous 10 slides with the features and names for that, it is given summarized here. We have two special features. This is a time and target. The rest of the features, this is the descriptive features. We refer to them descriptive, but they can be called as predictor variables, independent variables, and so on and so forth. Questions so far?
I think you cannot see the slide right now.
And now?
Yeah, now we see it.
Okay, so questions so far? If there are no questions, let's now to come finally to the visualization task. So we start, of course, with the importance of the visualization. Motivation, it's the important part. You remember our classical example to show the power of visualization is this dataset, as you can see here. So it's called ASCOM's quartet. You see again that we have 4 data sets. Every data set includes 2 features, x and y, x and y, x and y. And if we take the average, the mean, for the x, it's 9 for every x. If we take the variance for the x, it's 11 for every x. If you take the mean, it's for the y, it's everywhere the same. So what I told you before. But if we visualize every data set, then we could see that they are very different from each other. So this just gives us the idea of importance of the visualization. The other classical example is taken from this book. I will use some other examples from these books. It's a very classical examples of visualization. It's so-called Minard's chart. It's showing a Napoleon army trying to conquer Russia. I'm sorry, it's just examples and nothing to do with the current situation.
It's just an example.
Exactly.
It's fine.
It's fine. So it's so what you see here in that chart, that here the Napoleon army starts. You could see here that it was quite a lot of soldiers. So this brown color. Then it goes. So you could see here the different ways, the different towns. They will be pointed here. It goes to the Moscow. And you can see by the way it's less and less soldiers people stay. Then here the black line shows you how the soldiers then go back to their friends again. And you again can see that the line will be thinner and thinner because the less and less soldiers stays. And here you could see some of the soldiers goes to that town. In that case, you could see the temperature. So if you will try to explain the situation in words, you will need probably 2 or 3 pages to describe here. And just with one picture, you can show everything, and I can tell you 5 minutes and you will understand what the picture is about. So it's quite powerful way. So the visualization is quite strong and powerful way. Let's start. Before, you remember we were playing around with understanding the taxonomy, types of the data, and now how it's connected to the visualization. Let us focus first on the tabular data and the single feature. You remember we present our tabular data as the instances as rows and feature other columns. And here, if we have continuous features and we have the categorical features, how we can interpret them. For the continuous features, So you can look at the numerical features. We can say, for example, a number of instances. We can say the percentage of the missing. For example, we take one feature. It could be the age. We were talking about it's a continuous feature, age of our animal. Then what we can say about this feature, about the age, how many instances we have. We could say, so 500 instances we take, notice the age for the 500 animals. Then what we can add, from these 500 animals, we forget to add the age for 2 or 3 animals. So how many process? Cardinality. This is especially important if we have the ordinal features. Cardinality just say how many unique features we have. If, for example, we have continuous features speed, then probably we don't have every entry is unique. But if we, for example, have the features like refrigerate colors, which could be red, green, white, then it's probably we could have that the cardinalities that we have only 3 entries. This feature have only 3 entries: red, green, and blue. The refrigerator can have only one of these 3 colors. Just as an example. Minimum, you can say what's the minimum value, what's the maximum value of the feature. Then quantile, this is something special. If we take for our features, our values, for example, we have the speed and speed of the car here on the streets could be from, let's say, 10 km per hour until the 50 km per hour. And then we can count our all values which we recorded during the day for just for our cars. We can order them starting from minimum till the maximum, and then count, take the first fourth of these numbers, and that particular number in the middle will tell us that 20% of the data, the first quarter, is so 20% of the cars driving with the speed 30 kilometers per hour. So once again, how we can take this, for example, we take here all our examples. Assume we have the feature. The feature is just give us the age of the people. So our features give us somebody is 22 years old, the one is 19 years old, then we have 20 years old, 21 years old, and maybe 23 years old. Now we would like to compute what the first quarter is. First, what we do, we order this. 19, it's the smallest number. Then we have 20, 21, 22, and 23. And it somehow around here lies the 25%. So we will say that 25% of our students which is attending are until 20 years old. They are younger than 20 years old, 20 or younger than 20 years old. Then we can say 0.5% of our students are younger than 21 years old, and so on. So this is just explains what the first quantile is. Then we can take the mean value. Mean value just we take the sum and divided this sum of our values and divided this by the number. We can take the median just the number on the middle, We can take the third quantile, we can take the maximum value or the standard derivation. Once again, some of that terms, we will refer to them when we will look such visualization tool as a box plot. And we will again consider these terms in the details. So here is just again the description what I mean with the 25th percentage and 75th percentage. And here, so far, we were working with our categorical features. So, I'm sorry, numerical features, everything but have the numbers. If it doesn't have the numbers, we have another representation of that. For example, here, some of the descriptions of these categorical features are the same, like number of instances, how many instances doesn't have the percentage of the missing instances, cardinality, which item, how often occurs, mode. Here's the new term. It's the mode which shows about the what's the value comes the most often. How often comes this mode? For example, if we have 10, consider 10 refrigerators. 3 from those refrigerators are green, 3 of those refrigerators are yellow, and 4 of those refrigerators are red. Then red will have the highest mode, and the frequency of red will be 4. So here said the mode, actually the not, the second, the percentage, which we could say that the percentage of the red, its frequency is 4, and the percentage is around is a 40%. The same we can look at the second mode. The second mode, it will be that the value which take the second place by the frequency occurrence in the particular feature. And the same we can call, for example, in our case with the refrigerator colors, both colors, red and green, will be on this, or I said yellow and green, will have the second mode. Their frequency will be 3, and the percentage will be 30%. Questions to that? Again, what we are doing here, we saw that every feature could be either numeric or categorical, right? And now we would like to give us the first understanding of the features in order to do the analysis. And the first understanding is done in that way that we can build every feature in such kind of table. We have the table for the continuous features, like this one, and we have the table for the categorical features, like this one. For every feature, this table could give us some summary about this, like how often this features occurs, so that this feature was defined for all instances, or there are some instances where this feature wasn't defined. Then it gives us cardinality. For the continuous case, the cardinality is how many different features, different values in this feature. If we take the speed, then this cardinality could be that every entry has its own value. They are never repeating each other. If we take the color of refrigerator, then it could have that we have only cardinality of 3, because we have only 3 colors of our refrigerators, all possible values which our feature can take, color of refrigerator, just yellow, green, or red. We can have the minimum value and the maximum value. This is, again, for the continuous features. So like the minimal speed, it is 0 degrees that the car is standing, the maximum speed is 50. And we can take that the 25% of the cars driving with the speed 50 or less, and the third quantile about 75% of our cars. So this is for the continuous features. For the discrete features, we have slightly different table. Questions about that? You will see now it's a little bit more elaborated and there's some examples. So we have here the book. I just show you the reference. And from this book, you have such table. This is our data set. In our data set, we have our features. This is again our instances. You see the IDs. So what it means here that this is the 10th entry, 10th instance. Then from the 10th till 300, they just miss them. They didn't present them. But you
Nastya,
yeah.
We have more 10 minutes left, just for you to know, for this section.
Okay, thank you. Thank you for letting me know. So then now what I will do, I will introduce this example for you. And the next week, we will start from this example to see how we can visualize every of those features, which visualization techniques we can apply for every of those features. And moreover, we will see which statistical methods, which statistical computations we can apply for those techniques. But so far, that's just our data set. Our data set includes 500 instances. And this is the features of our data set. We have the type, it's type of the insurance. We have the income. We have the material status, as married or not married, and so on and so forth. So how many features? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13 features. So we have 500 instances and 13 features. Now, oops. So I think my iPad also noticing me that it's over. He doesn't want to present, so guys, he's like you. Okay. It's tired. No way. No way. Good. I think I will then finish. So just to make a sum up, what we did today, just to stop sharing. Yeah. What we did today was the following. In the beginning, I introduced you what the data science is. And you saw that the data science consists of the 4 steps. First, we need to take our data to store them, collect them and store them. Then we need to prepare our data. So we need to clean them so that they're in the nice, because you can think about cooking. If we put just all our stuff inside of the top and try to cook, it will not taste at all. We need to cut, clean. Then the second part, when the data are prepared, we could visualize them in order to answer the question, so what the data give us, to tell what the presence is. And the last step of the data science is to apply machine learning techniques in order to predict the future, in order to say, okay, if we will go to this way, then we will end there. So we can do some appropriate actions in order to change the situation. So that was in the beginning. Then we start to look why the visualization is important. And visualization, we start to look at when we have our data set, we can apply the statistical method like mean, variance, correlations, linear regression, and it gives us already some first feeling about the data. But very often this feeling is not sufficient. Like we saw the example that our statistical data are the same, but if we visualize the data, then they shows us completely different results. So we can We are motivated that we have to deal with the visualization. Now, in order to come to the visualization, we first need to understand. If we take our tabular data, then the rows are the instances, the columns are the features. And the feature could be different type. We could have categorical features, and we have continuous features. Continuous features, it's a numbers. Categorical features, it's a description of the object, like red, green, or it could be gender, female, male, diverse, and so on and so forth. That's the examples of the feature of the this type of categorical features. Okay, now we know what's the categorical and continuous, that our features could be one of those types. Then our next step, we have the huge data set. That was the last example. We have the huge data set, 500 instances, and this data set presented in the table, and it has around 13 features. And every feature could be either continuous or categorical. And then the first part, we can summarize every feature just by the some small simple table, which give us the first feeling about the data. And that was the last tables which I showed you about the data and about the features. So questions. I know it could be a little bit confusing, but think that we have the data set. Data set consists of many, many instances, and every instance are described by the features. And now what we want to think what tell us every feature. And every feature could have to be, unfortunately, different type. It can be categorical or continuous. And depending on this type, we need to use appropriate method to deal with them, to visualize them, to understand them. So, questions? No questions. Okay. I hope.
Yeah, if you do not have questions, we are going to have the next lecture in August 31st, and I think it's next week. Yeah,
next week,
Thursday. And perhaps you have a question till there. And I'm going to give you the presentation from Amanda from this week on financial, so that you have the material and can follow up, and you can show if you have some questions based on this material, okay? And I think, Danielle, could you stay a little bit there in the room? I would like to talk to you. Are you hearing me? Daniel, você está me escutando?
Ich? Yeah. Okay.
Hello? Hello?
Yeah, no, he is hearing me, sorry. Daniel, fica aqui depois do encontro, eu gostaria de falar com você.
Ok, desculpe.
Não,